what is the thing? Eighth person about to select, if he is having 1A, 1B, 1C. So 8th, 9th, 10th, 3 people are there. There are 3 distinct prices are there, can be arranged in 3 factorial. So whatever so far we got 1 by 24 into 3 factorial is equal to 1 by 4. Okay. But writing this one should be bit more clear. 8th contestant goes to the select price, means 8th person. See, missing point is 7 people selected, they got it to the 7, 4, 7 means out of 7, 4 A's, 2 B's, 1 C. That is fine. So 9th, 8th, 9th, 10th is not there. So here it should be it should have mentioned that one, the 10 prizes to given to 10 people already. What is the probability that, okay, when 8th person about to select, these were the options. So bit more clarity will be better. So first one is also correct. First one, what we have 1 by 24, what is that one? If you are not worrying about 8th, 9th, 10th. So 8th, 9th, 10th, those people, 3 prizes, 3 factorial ways. But if you are not worrying about that one, because as per this one, 8th contestant goes to select the price. He hasn't selected the price actually. Okay. So that's a difference here. Is it clear? Yes. So that is the 4th question. So why the 3 factorial is coming is only to distribute left out prizes to 8th contestant, 9th contestant, and the 10th contestant. Okay. Yes. 8th, 9th, and 10th. 8th, 9th, 10th. Sir, can you please tell, did you teach yesterday? You. Oh, what happened, beta? I think addition theorem I covered. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, and some problems we did. Okay. Yeah, before me forget, in the addition theorem only, you can write this one also. You have N of A union B union C is equal to N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of C intersection A plus N of A intersection B intersection C. In the probability, you divide with the total number. So P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of plus P will be there. So it is not only this one probability of A union, B union, C union, D, etc. Also, it will be sigma P of, okay, let me write A1, A2, A3, A4, etc. P of AI minus sigma P of AI intersection AJ plus sigma P of AI intersection AJ intersection AK minus etc. It's keep on, you can do. Okay, this is the addition theorem. Sir, ABC are same type of envelopes. So that's not an issue beta. ABs are any envelope means here. See, 1, 2, 3, etc. envelopes are there. Whatever the type, once you select whatever the thing, whether A is coming or B is coming or C is coming. Because in the first 7 factorial by 4 factorial into 2 factorial, during that time, we are keeping all the identical envelope repetition. So there is no problem. Two cubes have their faces painted either red or blue. The first cube has 5 red faces and 1 blue face. When the 2 cubes are rolled simultaneously, the probability that the top face shows the same color is 1 by 2. Number of red faces on the second day. No, don't do this one. This is a better thing. One we need to do. No, this is after conditional probability we need to talk about. Okay. This question is Bayes theorem, based on the Bayes theorem. Okay. Without Bayes theorem also, you can do this one. How it is? First phase, 5 red, 1 blue. Second one is X reds, 6 minus X blue. Both of them same color. So what is the probability of red is coming here? 5 out of 6, and here red coming is 6 out of X is out of 6. Are both are blue 1 by 6 into 6 minus X by 6 is equal to 1 by 2. So 5X plus 6 minus X is equal to 16. So 36 means 18. So 4X is equal to 12. X is equal to 3. This is better. Bayes theorem is okay, but they haven't talked about the probability. It is, we do this one. This or this. Next question is, A is one out of 6 horses entered for a race and is to be ridden by one of 2 jockeys, B or C. It is 2 to 1. It is 2 to 1 that B rides A, in which case all horses are equally likely to win. And if C rides A, his chance is trebled. Then the odds against is winning. Odds against is winning. Winning of A. So probability of B rides A. This is again conditional probability. This is equal to 2 out of 3. And probability of C rides A. This is the probability is 1 out of 3. Conditional probability. Okay. So what is the probability of A winning? If B writes A, this probability is 1 by 3, and the probability of A winning equally likely is 1 by 6. Now, R C riding A is 1 by 3. At that time, probability of A, his chances is tripled. Okay, so making 3 times more successful. So here what happened? A is there. There are H1, H2, H3, H4, H5, H6. So A winning is 3 times. So this is 3x, x, 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 x. Okay. So it is 5 only. 5x, 8x is equal, because 1 is going to win. X is equal to 1 by 8. So this value will be 3 by 8. So one important thing is chances is tripled. When compared to first one is tripled or second, we need to check it out. So here probability, let us work in this way. LCM is equal to, this is 18, this is, what is the thing? 24, 18, 24. What will be the fact? LCM of these two. Okay. Three into 24. 8 plus 9 is equal to 17 by 72. So if this is the case, probability of A losing, this is probability of A winning, probability of losing is 55 by 72. But there is no 17 case here. So maybe they're assuming here, their intention is, here probability of A is, here probability of A is equally 1 by 3. Maybe here probability of A is 3-fold. Let us try with 1 by 2. If it is 1 by 2, this is 1 by 9 plus 1 by 6. LCM will be equal to 18, 5. Okay, so this is probability of A winning. Probability of A losing will be 13 by 18. So probability of odds against. Odds against is this one is the answer. Okay. So chances is tripled means when compared to this one, the chances are tripled. Okay. So here equally likely 1 by 6. 3 times to 1 by 6 is 1 by 2. Okay. Next question is, you are having a doubt showing in the video. When I'm solving, why are you asking, beta? You can, I'll give time later now. Okay, okay, you keep your video. Let me keep your video. Which question? A symmetrical dice is thrown 4 times. The probability that 3 and 6 will turn up exactly 2 times each is. So symmetrical die is throwing how many times? 4 times. So 3 and 6 appears twice. So 1, 2, 3, 4. So 2 times 1 by 3 is coming. Probability is coming is 1 by 6, 1 by 6, 1 by 6, 1 by 6. But in this one, how many ways? 2 3s and 2 6s will come. So actually you have like 3, 3, 6, 6 can be arranged in how many ways it is? 4 factorial by 2 factorial into 2 factorial. Okay. So this, out of this, in which location 2 3s will come? So this one. So it is 4 factorial by 2 factorial to 2 factorial is equal 24 by 4 is 6. So 1, 6, 6 will be cancelled. 1 by 6 cube will come as the answer. You didn't understand the 9th question, somebody. So what is the 9th question they are talking about? A horse A is there. There are 2 jockeys are there, B and C. B may write this one, probability is 2 out of 3 times. C may write this one, 1 out of 3 times. If B is riding, it is equally likely to win in compare with all other 5 remaining horses. So the probability of winning is 1 by 6. If C is riding, whatever is winning, the chance of A winning tripled. So this will become 1 by 2. So probability of A winning is, you choose B, the probability of success this one. If you choose C, this is the probability. So probability of A winning is, first of all, B should write the thing and 1 by 6 is equal to 1 by 9. C should, next one, R, you give it a chance to C, that is 1 by 3, and winning is 1 by 2 is equal to 1 by 6. Addition of this one is probability of A. Odds against probability of failure is to probability of success is the answer. Okay. Next one is, lot A consists of 3G and 2D articles. Lot B consists of 4G and 1D article. A new lot C is formed by taking 3 articles from A and 2 articles from B. The probability that article chosen at random C is defective. Ayo. Oh. Maybe their intention, what I understand is 3 genuine, 2 defective articles. 4 genuine, 1 defective article. So A is having 3 genuine and 2 defective, and B is 4 genuine, 1 defective. We are forming C. From here, you will be getting 3 articles. From here, you are getting 2 articles. Probability that the article chosen randomly from C is defective. So, what are the cases? From A to C, the possibility is 3 genuine or 2 genuine, 1 defective, or 1 genuine, 2 defective. From B, two genuine or 1 genuine, 1 defective. That's it. Probability of 3 genuine is 3 out of 5. It's not 3 out of 5. What is this one? 3C3 out of 5C3. 3C2, 2C1 by 5C3. 3C1 into 2C2 by 5C3. 4C2 into 4C2 by 5C2. 4C1 into 1C1 by 5C2. Okay. Now look at here. Possibility 1 is 3G, 2G, 1D, 1G, 2D. And from here, 2G, 1G, 1D. So if you take these two cases, there is no chance of defective thing. In this one, what is the chance of this one? 2G, selection is 2G, 1D. This probability is 3 into 2 by 5C3, and possibility of this one is 4 by 5C2. After this one, in this case, how many defective items are there? Total defective items, 2 defective, 3 genuine. So 2 defective one, 2C1 by 5C1. Next, there is a chance of taking this one also. This is 3C2, this is into 5C3, and this 2 genuine probability is 4C2 by 5C2. At that time, total 5 out of 5, only 1 defective, 1 by 5S. Similarly, this into this and this one into this one. You write down all possible cases. You write all possible cases. You are going to get the answer. Okay. So you need to understand here what is the thing. So A is having 3 genuine and 2 defective. Here 4 genuine and 1 defective. So from this one, 3 articles are coming from this side. From this side, 2 articles are coming. You are packing a thing. What is the probability of selecting 1 defective object from here? Okay. So you need to study each case. See, from here 3, blindly you cannot transfer 3. If you are taking 3 genuine thing, what is the probability? 2 genuine and 2 defective. Every case you need to study. Okay. Please complete this question. So these questions are from which material? Why do you want these questions? And for this one, solutions are not available. Okay. Why do you want the material from which material? Huh? You, whether we are getting the good questions or not, only the important matter, better. Okay. So generally what happened, no, in any book or anything, I'll take the exercise question so that everything will be covered. Okay. Yes. Sir, I am not understanding how are you so how you are solving. No, we simple beta. Here these questions now you split into the parts. So here you have three genuine, two defective articles are there. Here you have four genuine and one defective is there. From this one, three possibilities are there. So what are three items need to be transferred? First, I'm transferring all three genuine. Second one, I'm transferring. Second case, I'm transferring two genuine, one defect. Third one, I'm transferring one genuine, two defect. For each probability will be there. Yes. Now from here, two articles. I'm doing two genuine, and next one is one genuine, one defect. Okay. So finally, what happened in the different cases will be there. What happened if I take three genuine, two genuine, five genuine will be there. Now three, so four genuine, one defective. See, look at here. This plus this or this plus this, you will be getting this case. Next one is three genuine, two defective. See, combination of these two you'll get, or combination of these two also you'll get. Next one is what is happening? Two genuine and three defective. So for this, each one, the respective probability will be calculated. Now from here, defective is selecting defective piece is 0. From here, selecting defective piece is 1 out of 5. From here, selecting defective piece is 2C1 by 5C1. Selecting defective piece is 3C1 by 5C1. Or 3 by 5, 2 by 5, 1 by 5. So, but for coming to this one, there is having the respective probability is there. So to reach this one, what happened? This and this. So what is the chance of this one into this one? You need to write. Yes. Your voice, Uday, your mic. Your mic. Yes, Uday.
So now it's coming, sir.
Yes.
Sir, I'm having a question also.
Yeah, tell me.
For I equal to 1, 2, 3, 4,
Hmm.
let Ti denote the event that
TI.
the Ti denote the event
Okay.
that the student Si and Si plus 1
Hmm.
do not sit adjacent to each other
Okay. Okay.
on the day of examination.
Okay.
The probability of the event T1 intersection T2 intersection T3 intersection T4 intersection T4 T3 intersection T4. Yes.
What is this one?
Asking the by of that.
Okay. See, what is the probability of T1? That means 4 people are there. Out of these 4 people, means actually you have S1, S2, S3, S4, S5 also there in that case. Because TISI plus 1 is okay. So these 5 people are there. S1 and S2 should not sit together. They are not supposed to sit. How many did they mention number of students, beta?
No, sir.
And have they mentioned how they are sitting type of thing, means in a row or what they mentioned?
No, sir, not mentioned something.
So maybe we'll assume 1, 2, 3, 4, 5 seats are there, beta.
Yes, sir.
T1 means S1 and S2 should not sit together. So what is the probability? So 5 people can sit in 5 factorial ways. And S1, S2 together, make it as a 1 unit. So S1 and S2 is 1 unit. So what will happen? This is 1, 2, 3, 4. So there
4
is
factorial.
4 factorial into 2 factorial.
2 factorial.
So which is equal to 2 by 5.
Yes.
Probability of T1. Probability of T2 also same thing. Probability of T3 also same thing. Probability of T4 also same thing. Now here T1 intersection T2 intersection T3. So if you typically look at here, for example, S1 comes here, student 1, S2 should not be there.
Yes, sir.
1, 2, 3, 4, S1, S2, S3, S4, S5. Okay. So here S2, it cannot sit here. S2, you have the 3 places. For example, S2 is sitting here. Okay. Now S3 should not come here. S3 should not come here.
Yes, sir.
So you have S4 only 1 chance. S3 only 1 chance here. Okay. So now for S4, S4 cannot come here. So S4 has to go here and S5 coming here. So this is happening, okay, one way. Now, for example, here instead of S1, somebody else is coming. How we can take? You just look at S3. Now S1 is here. For example, S2 is here. For S3, this is not the place for S3. This is not the space for S3. S3 has to be sitting here. If S3 is here, S4 cannot sit here. So S4 has to sit here and S5 need to sit here. Okay. So you just look at how many things are going to come. Okay. Because these are the ideas I'm giving without moving into the further level of the things. Okay. Because we haven't covered the many concepts. So that's why without touching that one, independent events and conditional things, etc. Without using, I'm looking at this one. So how many are going to come this way? So here, if S1 is here, actually what happened? These people are going to sit in the, how many ways? They are not sit adjacently. So that one, you will be getting 3 ways. And if S2 comes here, 3 ways. S4, this one. So what I feel is 15 by 5 factor. What is the answer is given, beta? Who is asking this one? What is the answer is given for this question? Where is he? His mic is my audio is audible to you people. Yeah. So it should be what my gut feeling is going to be, because when you are fixing up S1 in the first position, you will be getting 3 ways. When you are fixing up S2, this is a different event. 3. S3, this is 3. S4, 3 ways. S5, 3 ways. That is what I'm assuming. Okay. So I'm just went for S1 here. S2 cannot sit here. I can go ahead with S2. So S3 cannot sit in these two. So here S3. S4 cannot come here. S4 and here S5. Next, S1 is here. S2 is here. So S3 will not come. S3, you have the only one place. S4 should not come here. So here S4, here S5. Now, S1 is here. I'll be going with S2 here. S3 cannot come here. S3 cannot sit here. Okay. So S3 can be sitting here. So at that time, S4 should come here. So S4, there is no chance. So S3 will not sit here. So what will happen? S3 should come here. S4 should come here. S5 should come here. So these 3 ways. For example, S2 is sitting here. 1, 2, 3, 4. Now S1 is not chance. S3 also no chance. So you write S4 here. S3 here no chance. S5 also no chance. So S1 you can write. You can write here S3 and you can write S5. Or you can write S5. You can write S3. Oh, number of chances are increasing because S1 is, there is no preceding term, but here succeeding term is there. Now, S2 is there. It's more. Yes, Uday.
Sir, answer is given as 7 by 60, sir.
7 by
60.
Okay, 5 factorial is 120. So you are getting 14. Okay.
Yes, sir. Yes.
Okay. So for S2 is here. S4, S1 has to come because S3, S5 will not there. S5. So these are the 2 chances we got. Now S2 you are writing. Here if I write S5, what is the thing you left out with? S3, S1, S3, S4. So S3, S4, here S4 will not come. For example, S1 is coming here, S3, S4 will be adjacent. So here what happened? You need to take S3 here, you need to take S4 here, S1 is here. Are interchangeable. You
Yes,
are
sir.
going to get 2 more.
2, sir.
Now you go ahead with S3. What are the cases are going to come? Yes, Shiva?
Sir, if you interchange, then S4 and S5 will be beside now, sir.
Right. So only one chance. No chance. No other chance. Only one chance. That's good, better. That's why good. Okay. So S2 is that? Yes. Yes, only one chance is going to come. Yes, Vamshi?
Sorry, no, yes. You wrote first 3, no, sir, for S1. There also thought you wrote S5 and S4 adjacent.
Oh, did I write?
It's a third one. It's
Uh-huh. Okay. S3 is there. So it will not be. Oh, okay. So this is only 2 cases only. Then it is 2 cases only. So you have to go for that one. Okay? Uday?
Yes, sir.
Yeah. Same way you work it out. And one question here.
14 I'm not getting, sir. I'm getting only 7 or 6 I'm getting.
No. You get, see, for each one you are getting 2 or 3 items, no? For S1 you got 2 items. S2 we got already 3 items. You look at what is S3, S4 and S5 is getting. Okay.
Sir, you asked lastly intersection, no, sir.
No, we are writing that intersection only directly we are writing, no? I'm writing that final case only I'm writing.
Both are common. All are should be common.
No. What common beta? I'm writing S1 is S2, S3, S4, S5. So note these are not together only we are writing.
Yes, sir. Okay.
Next one. A bag contains 10 balls. 7 are drawn simultaneously and replaced. Then 5 balls are drawn. Probability that exactly 3 balls are common to 2 drawings. Okay. So actually here, what is now? This is the conditional probability only. Somebody's asked, this is also conditional. We'll discuss later that one. Okay. 11th question. Right. Yes, Chandrakant.
Hello, sir.
Yeah, tell me.
Sir, I sent you a question, sir, just now.
When did you send?
That one P intersection, A intersection, B intersection, C, that one, me only, sir.
P intersection. What is your mobile number ends with?
9674, sir.
Okay. So all of you look at this question is P of A intersection B is equal to 0. P of A union B is equal to 1. P of A intersection C is equal to 1 by 5. P of C is equal to 7 by 15. P of B intersection C is equal to how much? This is the universal set. I'm splitting into this is A, this is B. So there is no common portion. A union B is equal to 1. It is completely taking the universal set. Complete sample space it is taking. Then A intersection B, C is something is there. A intersection C is 1 by 5. Probability of C is 7 by 15. So this is 3 by 15. So this portion is 4 by 15. Okay.
Okay, sir.
So with the diagram only, we got the answer. Right. What is the 11th question? A and B have two bags containing one ball each of these. A randomly selected one ball from the bag into the B. Then B is selected one ball from the B put into the A. The probability that after this process, the contents of two bags are same is. You need to complete 11, 12, 13, 14 now. Please make it fast and It may take some time initially to solve the problem, but don't give up. Try to practice. Okay. Yes. So I'll explain the first question, how we are supposed to approach. Okay. What is the first question is, A is having one blue, one green, one orange, one red. B is also having one blue, one orange, one red. Oh, 1, 2, 3, 4, 5. Okay. Blue, green, orange, red, violet. Blue, green, orange, red, violet. A randomly select one ball from his and put into this one. And then B selects one ball from here and puts it back. The probability after this process, the contents of two bags are same. So from here to here, how many ways we can transfer? 6 ways. From here to here, how many ways we can transfer? 6 ways. So total number of ways will be 36. Out of them, B to B, and means you are transferring B, you are transferring B. Or you are transferring G, you are transferring G. You are transferring or transferring. So this is 6 are favorable. So answer will be equal to 1 by 6. Okay. Yes.
Hello, sir. Hello,
Yes.
sir. Are you able to hear me, sir?
Yeah, tell me.
Sir, how can we transfer in 6 ways, sir? That did not understand, sir.
Okay. No, I think answer should be, I'm getting my doubt is maybe instead of this, I think 1 by 3 could be the answer. Just let me check what is the answer. 1 by 3, I got some doubt here. 11th question. 11th question, B. Yes, 1 by 3, right. Thank you. When you are asking, I got that thing, clarity here. Some point is missing. C. When there are, oh, actually we have 1, 2, 3, 4, 5 only, no? Why I thought 6?
Yes, sir.
Yeah. Now, here blue ball I'm transferring. So now it will be 2 blue balls after transfer. 1 green, 1 orange, 1 red, 1 violet. So this is transferring. How many ways you transfer this one? 5 different ways are there. Okay.
Yes, sir.
So first we are transferring 1. Now here I have 6. Out of that one, to maintain the same thing, whichever the ball comes, I need to transfer the same ball. So 2 out of 6 ways. Yes or no? Because 2 balls are there, 1, 2, 3, 4 different and 2. So out of this one, if I transfer the same ball, it remains same.
Okay, okay, sir. Understood,
Okay.
sir.
So it will be equal to 1 by 3. So whichever the ball you choose, here that ball will be doubled. So I need to transfer the same ball. But when I'm transferring, what happened? The same color ball, there will be 2. Okay. So here what happened? You can write 1 by 3 direct. Okay. A bowl has 6 red marbles, 3 green marbles. The probability that blindfolded person will draw a red marble on the second draw from the bowl without replacing the marble from the first. Oh, there are 6 red, 3 green. First one, which one we picked, no one knows. But in the second one, he need to pick the red one. What is the probability? So, in the first draw, without replacement, I am picking the red ball. So how many balls will be there? 5 red, 3 green. So from here, picking a red ball will be 5 by 8. In the first draw, if I'm picking the green ball, you'll have 6 red, 2 green. So picking the red ball is 6 out of 8. But the probability of picking a red ball here, it is 6 out of 9. Picking the green ball here, 3 out of 9. So what is the answer will come? This is 6 out of 9 into 5 out of 8 or 3 out of 9 into 6 out of 8. So this is 9 into 8, 8 into 6. Okay. So you can go ahead with 2 out of 3. Okay. Yes. Try to do the 13th, 14th. Please make it fast. Yes. Next one is 13th. I hope you people must have got the thing. What is the 13th question? Two cards are drawn from a well-shuffled pack of 52 cards. One by one. The event that second card is drawn is ace. Okay. Event that first card drawn is ace. So first let me talk probability of B. First one, I am selecting 52 cards. I have 4 aces. So it will be equal to 1 by 13. Now probability of A. If the first card is ace, okay, first one is with the well shuffled one after one means when you're taking here, you need to understand one after one. So one after one means whatever you take the first one, you're not replacing. So when you're going for the second one is, first one is, if it is A's, what is the probability of picking the A's? 4 by 52. Now second one also yes. So you have only 3 by 51. Okay. Or if the first one is non-A's, second one has to be A's. Okay. So that is 4 by 51. So what is the thing? 52 into 51. So you are getting whatever this thing is. Look at here. 4 common 51. It is equal to 1 by 13. Something is missing. Is something. Is it right? So the first one is, see. Let me look at the second one once again. Probability of A. What is the probability of A? The event that second card drawn is Ace. So first card is Ace plus second one is also Ace. This is one case. First one is non-Ace plus second one is Ace. And so first one is Ace here. That is 1 by 13. Now we have 51 cards. Out of that, only 3 aces are there. Second one is non-ace. That is 12 by 13. Because for now, there are the 4 aces out of 51 cards. This is what this one. This are this. So this is equal to 1 by 13 into 17. Sorry, this 3 ones are 317s. Now this is 3 4s are 317s. It's equal to 16 by 13 into 17. So this are this addition of this one. Yes, 1 by 17 is going. So this is the answer. Okay. Yes, Dheeraj.
Good morning, sir.
Good morning.
Sir, in 13th B, we need not to consider second card, sir.
In which one?
13th B, sir.
No, here only we are concentrating on only on the first card.
Yes, sir. Thank you, sir.
Yeah. Shiva?
Sir, in 13th B, we can't take 4C1 by 52C2, sir.
No. In this one, which one?
Sir, in B, sir.
In B, no. Oh, you mean to say 52C, 52C2, 4C1, you mean to say?
Yes, sir.
No. Okay.
Why,
Because
sir?
the first one trial is different from second one. They're not taking two together simultaneously. Okay,
sir. I got
taking
it.
simultaneously is different and taking one after other is also different.
Yes.
Yes, now maybe you look at now 14, 15, 16. Then I think we went for up to addition theorem. No, we need to go for the other things also. Conditional probability also we need to go. Yes. So 14th question, how many of you got it? So the 14th question is, an arm contains M white balls, N black balls. All the balls except for one ball are drawn from it. The probability that last ball remaining in the on is white. Okay. The ball which remains is white. So you are picking the first ball, second ball, third ball, everything is picked up. Okay. So they are asking only the ball, the last ball has to be so one white ball need to be. So you are picking first one, second one, third one, but finally there should be one ball. Simple it is. Whatever the last ball, I'm selecting first directly. So how many balls are there? M out of M plus N balls. So this is the answer. It is simple. Picking the first ball as a white, as same as the keeping the last ball as white. 3 numbers are chosen at random without replacement. The probability that the minimum of the chosen number is 3 or their maximum is 7. Okay. So either whatever the number A, B, C is selected, either 3 or 7 should be there. Okay. Here actually you can go for the addition theorem of the probability. So minimum number is 3. So 3, 4, 5, 6, 7, 8, 9, 10. One number is selected. One number is selected. So you need to select 1, 2, 3, 4, 5, 6, 7. So that is 7C2 by 10C3. Or you are selecting B, probability of 7. Maximum is 7. Because your minimum 3 should be there. That's why I'm writing. Maximum is 7. So 1, 2, 3, 4, 5, 6. So 6C2 by 10C3. Minus 3 should be there, 7 should be there. Combination. In between, what are the numbers? 4, 5, 6. 1 out of this one. 3C1 out of 10C. Okay. So 10 into 9 into 8 by 6. 7 into 6 by 2, 21 plus 6 into 5 by 2, 15 minus 3. 12, 33, 6 by 10 into 9 into 8. Can we write? Or is there any other way? So here very simple is 3 numbers are chosen. Either minimum is 3 or maximum is 7. If 3 comes, the remaining can be anything from here. If 7 comes, anything from here. So in this process, what happened? No, this quota is repeated. You subtract that 3, 7, 1 among this one. Okay, that is the case. You'll get the answer. At least one child in a family with 3 children is a boy. then the probability that 2 of the children are boys. Actually, this is conditional probability, but theoretically, if you go too much, so at least one child in a family of 3 children. So what is that possibility? Let me write 8 possibilities. BBB, BBG, BGB. I'm just, without applying my brain too much, I'm writing all cases. 3 children means only 8 possibilities. Okay. Now in this, if at least one child of the boy is a boy, so they are not considering this one. Okay, so they are considering this, at least one boy is already known to us. Then what they're asking, then the probability that 2 of the children are boys. So what are the possibility? 1, 2, 3. 3 out of 7. Actually, this will study in the conditional probability by taking the what is the thing, but not required. Whatever the condition, I'm writing the sample space. This one is ruled out. So out of this one, what is our favorable case? Okay. Yes, Raghava.
Sir, what is difference between BBG and BGB, sir?
BBG. No, 3 children. First child, second child, third child.
Okay, sir. Okay, I got it, sir.
No, if you are not attended one class because of power failure, etc., because I can't repeat that question, no. Yes, 16th question. Here, at least one child of a family with 3 children is a boy. So 3 children, how many possibilities are there? 8 possibilities are there. So first child can be boy or girl, second child can be a boy or girl, third one also can be a boy or a girl. So 8 possibilities, but they clearly mentioned one of the child is boy. Minimum one child is boy. So all the 3 girls case ruled out. So out of 7, so how many are pending? How many are favorable? 2 boys. Those are 3 are thing. So 3 out of 7. 14th question is the last remaining ball is white. So I'm keeping that one is first. I'm selecting that one and keeping aside. So that is m by m plus n. Yes. See, here the 17th question we need to talk about. So what happened? 7 persons are stopped on the road at random, ask their birthdays. If the probability that 3 of them born on Wednesday and next one is 2 of them on Thursday, remaining 2 on Sundays. What is the probability of that one is? What is the K value is equal? Come on, make it fast. Yes, anybody got the answer? Who did the answer? Yes, Satvik, can you tell me what is your answer? Satvik. Satvik, yeah.
Hello, hello, sir. Sir, 30 I got, sir.
How did you get?
Sir, probability of 3 people on out of 7 born on Wednesday, no, sir.
Yes.
I had taken 7C3 by 7 cube.
7C3 by 7 cube.
And 2 people out of remaining 4 born on Thursday, no, sir.
Okay, so 4C2
2
into.
by 7 square.
Okay.
They, again, remaining 2 born on Sunday, 2C2 by 7 square.
Okay, that's
Sir,
it.
yes, sir.
Yes. So it will be because everyone is independent actually. So this is 7 power 7 and 7C3 into 4C2. 7 factorial by 3 factorial into 2 factorial into, or sorry, 4 factorial by 2 factorial into 2 factorial. 4 factorial cancel. So this is 6 factorial into 7 will be cancelled, 7C. So 6 factorial by 3 factorial into 2 factorial into 2 factorial. So what is 6 factorial? 6 will be cancelled, 120. 120 by 4 is equal to 30. Next one is a box has 4 dice, 3 of them are fade dice. So probability of getting everything is same. The fourth one has the number 5 on all of its faces. A die is chosen at random from the box and rolled 3 times and show up the face 5 in all the 3 occasions. What is the chance of the dice chosen die is? Rigged die is. So it's a manipulated dice or faulty die. So in this one, 3 dice are proper dice are there, one is the wrong dice. So probability of picking the, actually it is the conditional probability. Actually this is probability of A given B, etc. But I am trying to teach you without touching that point, because if I teach this way, when that question comes, it will be easy. So total possible ways I am writing these three. So this is 3 out of 4, and getting the whatever the thing you are getting after that one, getting the 5 on this one is 1 by 6. 3 times, so 1 by 6 whole plus. If you are picking a defective piece, that is 1 by 4, every time success. So this is the probability of getting 5 on this one. So out of this one, favorable case is this one. Okay, so 1 by 4. So 1 by 4, 1 by 4, you go for this one. Okay. Otherwise, just you leave this one. We'll come back to this one after teaching the conditional probability. Let me go for the conditional probability part now. Okay. I think we stopped yesterday at that position only, right? At the conditional probability only. Yes. We stopped at what is the conditional probability. Let A and B be any two events associated with the random experiment. The probability of occurrence of event A when the event B has already occurred is called the conditional probability of A when B is given, and it is denoted by probability of A given B. The conditional probability P of A given B is meaningful only P of B is not equal to 0. So what is this conditional probability? Simple. Okay. Now, Mr. X driving a car, and already we know that he has a valid driving license. Now, probability of he met with the accident when we knew that he has the driving license. So, A can drive the vehicle in two conditions: without driving license, with the driving license. So here I knew that he is having the driving license. Means what will happen actually? Probability of A is equal to what is the chance of not having the driving license? Okay. Or what is the chance of driving the car with the driving license? So here what is the thing is, probability of A given B means this event B is already had occurred. Okay, see, when this event B. So you are talking about this is the universal space. You know that this event has already occurred. A is this one. What is the probability of occurrence of A? So here this is A intersection B. So chance of occurrence of A is probability of A intersection B out of probability of B only or not? Because this is the universal set, but I am sure that this is already occurred. In this one, what is the chance of occurrence of this? Okay, so what is happening? So here number of elements in A intersection B, by out of this one only you need to consider probable number of elements in B. But number of elements in the universal set N, you can write by N by N. The moment you are writing this one, this is probability of A intersection B by probability of B. So probability of A given B, we'll read it as probability of A given B is equal to probability of A intersection B by probability of B. Probability of A intersection B by probability of B. Okay. So this is called the conditional probability. Okay. Once again, I'll explain with one simple example. See, Mr. X visited his friend Y some 20 years back. At that time, this X has one child that was boy. So Mr. X knows that Y has a boy. Now, after 20 years, he has 2 more children. Now, what is the probability of Y having 3 boys when we knew, okay, 2 boys when we know 1 boy already exists? So what happened? 3 kids. So the possibility is boy, 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 BBG, BGB, GBB. Next one is GGG, GGB, GBG, sorry, GBG, yes, BGG. Now, when X knows the first one is boy, so there is already 1 boy. So this case is ruled out. This case is ruled out. So instead of taking the entire sample, you can look at this one. In this one, what are the chance of getting 2 boys? This case is okay, this case is okay, this case is okay. So 3 out of 7 directly. So now what happened? Probability of 2 boys. If I take probability of 2 boys out of total thing, 3 out of 8. Probability of 1 boy is equal to 1 boy, means at least 1 boy. At least 1 boy is, what is 1, 2, 3, 4, 5, 6, 7. 7 out of 8. Now, probability of 2 boys intersection at least 1 boy will be equal to, what is the thing you need to go ahead? 2 boys, at least 1 boy will be 3 out of 8. Now this value will be 3, this 1 by this. Okay. So what we are doing here is, when the universal set sample space is there, n of S is equal to n, capital N. But what we have identified is, this event already occurred. This event already occurred. What is the chance of occurrence of this? So this event B already occurred. And what is the chance of occurrence? So in this B, what is the occurrence of chance of occurrence of A is only this one. So what is this portion? This portion is simply A intersection B. Now probability of A, when we knew that B already occurred, is number of elements in A intersection B by number of elements in B, which is equal to number of elements in A intersection B by N by number of elements in B by N. So which is equal to probability of A intersection B by probability of B. So this is what we will write. Probability of A intersection B is equal to probability of B into probability of A given B. Or you can also write this one as probability of A into probability of B given A also. This is called multiplication theorem. Now, if occurrence of A given B is not depending on the occurrence or non-occurrence of B, means P of A intersection B is equal to P, means occurrence of B is not affecting the occurrence of A, or probability of B given A is equal to probability of B. So what we are calling as A comma B are independent events. Independent events means occurrence of A is not affecting, occurrence of A is not affecting occurrence of B. So in this case, what we will be getting? In this case, you will be getting probability of A intersection B is equal to probability of A we are writing. So probability of A intersection B is equal to probability of A intersection B, probability of A given B is equal, sorry, probability of B is equal to probability of A. So what happened? Probability of A intersection B is equal to probability of A into probability of B. What we call? These are called as independent events. So when they are independent, probability of A intersection B is equal to probability of A into probability of B. Not understanding this concept, you switch on your mic better, then I'll tell you. See here, what is this one is A given B. You need to understand what is this meaning of A intersection B. So the event B already occurred. What is the chance of occurrence of A? Means it is like probability of, okay, you scored well in intermediate first year. What is the chance of performing well in the second year? So we knew that first year performance is good. What is the performance of second year? But actually first year performance, frankly speaking, not affecting this one. So directly you can write probability of second year performance. Or if you take the this one recent pandemic, what is the probability of second year score when we know the first year score? It is purely depending, because in the recent exam, what happened for all the outgoing seniors, second years, they have given this mark same as the first year. Okay, so when the first event already occurred, what is the chance of second event? Okay, so instead of looking at the entire, because actually probability of A means you need to take this is a favorable out of this total. Instead of this one, in this case, what I'm concentrating only this one, because this event is occurred already. So when this event already occurred, what is the point of looking at everything? Not required. So you need to look for this event only. Okay, so that is what the conditional probability. when I'm teaching some concept, please don't send the WhatsApp message saying that when I explain this or that. Right. So conditional probabilities, number of favorable cases A intersection B by total number of cases favorable to B. That is probability of A given B. Okay. So it is meaningful when the denominator is not equal to 0. Yes. With some examples, you'll understand. The people who are not understanding this one, just pay attention. What is this question? Roll a fade die twice. Okay. And A be the event that sum of the two rolls equals 6. Let B the event that same number comes up twice. What is the probability of A intersection B? So let me write what is event A. 1, 5, 2, 4, 3, 3, and 4, 2, 5, 1. What is the event B? Event that same number comes up twice. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Now, what is the probability of A given B? What is the probability of A given B? What is this you write? Means probability of sum of 2 is 6. Given that event B, what is that one? Same number. Comes up twice. So do we need to look for the total possible 36 outcomes? Not required. Instead of that, we can just concentrate on this one. In this one, how many are favorable? Is sum is 6? No. Is sum is 6? No. Is sum is 6? Yes. Is sum is 6? No. 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 So what is this one? Directly 1 out of 6. 1 out of 6. Or you can write this one. Now, probability of A intersection B by probability of B. So what is the probability of all the equal numbers out of 36? 6 are favorable. So 1 by 6. A intersection B. Common case is 1 out of 36. So this is 1 by 6. You can do. So instead of that one, you can restrict yourself instead of all sample space. You can go ahead with this one. Okay. Is it clear comparatively? Is it okay? Now, next one also I'll quickly explain, maybe useful to you. In a class of 30 students, out of 30% failed in physics, 25 failed in maths, 15 failed in both physics and chemistry. If a student selected random failed in mathematics, find the probability that he also failed in physics. So, probability of he already failed in maths, what is the probability of failed in physics also? So just you take, if there are 100 children, this is failed in physics, this is failed in maths. Both 15 people are there. Physics 30 means it is 15. In maths 25, so 15 over. So this is 25. So this portion is 10, this portion is 5. Now, if a selected student failed in mathematics, so now in this one, these are our students. Out of this one, how many failed in physics? 15 only. So total 15 out of 25. So it is equal to 3 by 5. So that means how much? 60% of people. Okay, 60% you need. Okay. So what happened? Already I'm concentrating only the number of students who failed in maths. Sir, can you explain question 1? Confused. No, if you give the mic, you switch on the mic and tell me where you have the confusion. Okay. I clearly explained. What is this one? Probability of A given B. That means I knew that same number appears twice. So these are the 6 possibilities. Out of these 6 possibilities, what is our sum? Should be 6. So only one is favorable. 1 out of 6, I wrote this one. Or you can theoretically, if you want to go for this one, really of not required. Theoretically, we'll go if it is unavoidable. Otherwise, we'll go for the straightforward. And similarly, here what happened? When I knew a student, if a student selected random failed in mathematics, find the probability that he failed in physics also. So I'm selecting a student failed in mathematics, and now I'm selecting what is the chance of he failed in physics also. Okay. Yes, you try this one. Very simple here. Here bars are given. So probability of A bar given B bar is equal to probability of A bar intersection B bar by probability of B bar. Sir, if it is P of B by A is, then it is 1 by 5. What 1 by 4? Which one? I don't know which one he is talking about. I don't know why these people. Oh, you are asking B by A. In which case here, in this case, what is P of B by A? Better one question is there. No, why you will ask that one? Okay, B by A. So when we have the, yes, A is given 1 comma 5, 2 comma 4, 3 comma 3, 4 comma 2, and 5 comma 1. In this one, yes, because only this one. Yes, that is right, beta. And please don't do such things. Now, when the question is there, you concentrate on that question. Otherwise, you take the mic and ask. I'm seriously telling, I think I need to stop looking at your comments, or I need to remove the people who are putting the comments there. Yes, concentrate on this one. Yeah, I was explaining something. What was that? Probability of A bar given B bar is equal to probability of A bar intersection B bar by probability of B bar. It is equal to 1 minus probability of A union B by 1 minus probability of B. Okay. So Here probability of B given A is equal to probability of A intersection B by probability of A is given. So you find out this and recalculate back. Okay, please. Make it fast. S. So what is this one? From here, this is equal to 1 by 2 is given. So probability of A intersection B is equal to 0.3 by 2. So 0.15. So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B is equal to 0.75. Probability of A union B whole bar is equal to 0.25, which is equal to probability of A bar intersection B bar. So is equal to 0.25 by probability of B bar is 0.4. So 25 by 40, 5 by 8. Okay, 5 by 8. Now multiplication theorem on probability. This is already we discussed. So the same thing will be repeated tomorrow and we'll solve some more questions. But one important thing is the most important thing for this chapter is keep practicing the questions. Okay. So I know this weekend you have the exam on what is that? Combinations. So don't neglect these permutations, probability also, because in the probability also you are repeating twice. In every question, numerator is one permutation combination, or denominator also same thing. Okay, so maybe on combinations I'll try to give questions on Saturday, but tomorrow also I'll continue with this probability only. Okay, so if everything goes well, we get maybe if we get some couple of days additional, we can look at the area, small areas like see progressions where you require some doubts, etc. can be covered. Okay. Thank you very much. See you tomorrow. Any information about your college opening? Did you get any? No. Okay. Are any of your friends got the call? Anything? Maybe this weekend they may decide. Yes, Shashivardhan.
Sir, yesterday when I was talking to my friend, sir, who is studying in N120, sir, Kondapur only, they have English and Sanskrit second year, sir.
Oh,
Second year
yeah.
English.
Yeah, I know them. Some scheduled classes are happening. English and
Yes, sir. There, Babji sir said that N120 will come at 6th September, it seems.
So you will be there in the first phase September. Then in that case, obviously,
Yes, sir.
they'll call. See, batch wise they call and they'll arrange the people. Okay.
Yes.
Okay. Can you please explain sequence series? Yeah, if time permits, we'll see. Okay. Thank you. See you tomorrow. Bye.
Bye.